Okay, students, welcome back. So I'm starting that video again. I've been in between. I will also give the commentary so that you can understand the thing. Okay, so hope screen is visible. Screen is visible to you?
Yes, sir.
Yes, sir.
Okay, so now I'm playing it.
I have here this lovely little gel.
Okay, so as you are able to see here, so in hand what is she's having? She's having gel casting tray. So first gel casting tray is open from two sides. So first means as it is open. So if you add a liquid, so it means gel as when we're talking is agarose gel. So agarose gel is agarose. You all know that it's a solid substance, but it is insoluble in water. But if you warm your water, if you boil your water, then it dissolves in water. And when you cool it down, then it gellify. So this is the thing. So in the liquid form, in the dissolved form agarose, you have to pour it. So if you pour your liquid into open as is container, then it will spill out. So to prevent that, we are sealing it from the ends. So this is the sealing, how to seal it.
And I'm going to seal the ends of this mold with just regular old masking tape.
So this is a regular tape that you are having.
Down with ethanol. So we're going to push down
this is
just like
you just seal the ends. So two ends are open because these two ends are for your
push
conduction of the
sure
electricity.
that when we pour our agarose in here, that it doesn't leak. And we'll do the same thing to the other end. So that should do it. Now, a lot of people put their comb in after they pour their gel, but frankly, I've never seen any difference. I've never seen, for me, any bubbling around the teeth of this comb. So I just usually put the comb in immediately. Now,
so after sealing it, you have to place the comb. So comb generally we place half to 1 centimeter from any of the edge, any of the open edge that is there. So just a 1 centimeter or less than 1 centimeter away from that, you have to place the comb. So comb where you place, it is going to form wherever these combs are there. So they are going to displace the gel and they will form a impression there. They will form a cast there. So the impression that we are going to give, the whole type of things to them we are going to call the well. So whatever the shape of your comb is there, so see a similar shape of the well you are going to get. So here it is going to simply, you can see it is sphere rectangular type. So your wells are going to be also rectangular in shape.
make the regular agarose gel. So I'm just going to move this out of the way for a minute. And I have here in this little weigh boat.
So this is agarose you have to weigh, 1 gram agarose weigh.
About 0.32 grams.
This is 0.32 grams, so means the volume that you want to make it is accordingly changed. If you are making 100 ml, so accordingly whatever the volume you are going to make, you have to make your weigh your agarose.
So I have here 250 milliliter Erlenmeyer flask. I'm going to pour in the agarose into this Erlenmeyer flask. And I have my 1-time EDTA buffer that I'm going to put in.
So here the gel also you have to make in the buffer. So there she's using 1xTAE buffer. So the volume of the buffer she is adding.
The flask. And I'm also going to wash out the label with the buffer because, of course, some of the aggregates get stuck to the label. There we go. We have to melt that agarose. So we're going to take it to a microwave. We're going to microwave it on high, about 40 seconds, till it boils, and then we're going to come back. Okay, so we've melted the agarose in the microwave, let it come to a boil. Now we're going to let it cool down, and we're going to put a magnetic stir bar that's been sterilized into this flask. And then we're going to turn the stir plate onto its lowest, lowest setting. And it takes 2 or 3 minutes for that to cool down. And while it's cooling down, we're going to set the pipette. We're going to put in 64 microliters of loading dye. So nice and easy, pretty wet. It's cool enough, still very warm to the touch. Don't want it to solidify in the flask. And there's the 64 microliters dye that will help us visualize the bands of DNA. Now that looks evenly dispersed, that dye. So we're going to take a couple of large magnetic stir bars to anchor the small one that's inside. And now we're going to slowly pour this agarose gel. And that'll take 20 or 30 minutes to set. So 0.8% regular agarose gel took 20 or 30 minutes to set, harden. And I just put it down into the gel rig. The rig has the same buffer that we made the gel with, 1 times TBE buffer. It's been sitting in there for a couple of minutes because we want the buffer to be able to get around the teeth of the comb so we can easily extract the comb. And then after we do, we're going to put in the DNA that we digested overnight using restriction enzymes. And then we're going to run. Make sure that you're anchoring, holding down. I'm going to take this comb out. This is our DNA standard, our ladder. And putting in 10 microliters of ladder. And here we go, there's the well. Nice and slow into the well and down into the second stop. And release the micropipette plunger. And now we're going to get a fresh tip for every sample. This DNA is digested with only 1 enzyme. So we know where this enzyme leaves the DNA. This enzyme is PST1. And we're going to load that. Second well. Loading. There we go. Excellent. This third vial is digested with PST1 in the second restriction in the days. So we're going to have DNA of different sizes. This has been digested with 3 restriction enzymes. So we'll have multiple bands of care in this well. Down into the well. And voila. 130 volts. And when I set the voltage, I hit one button, and there we go. Now this can run between 45 and 60 minutes. Of course, the smaller fragments of DNA, the smaller bands or fragments, will migrate much more quickly through the gel, and they'll be closer to the end of the gel, whereas the larger fragments of DNA will not be able to migrate as far in the gel because of their mass or size. And when that's finished running, you'll see that small band of bromophenol blue near the end of the gel. That's when we're going to turn it off. And then we're going to look at our bands on light. So we have run this 0.8% agarose gel at 130 volts for 45 minutes. And we turned it off, and we stained this with a small amount of dye for 20 minutes. And then we stained it, rinsed it in ultra pure water for another 20 minutes. And you can see now we're going to look on the light box. Slide this right off onto the light box so that we can look at bands. And you can see here was our DNA ladder, the standards of known sizes. And look at the banding patterns that we have with these different enzymes, banding patterns of DNA. So we can now tell the sizes, the unknown sizes of DNA by comparing to standards. And this is very helpful to have very important information to help characterize any novel DNA that we may be examining.
Students, so hope you enjoyed this video, and okay, so hope you enjoyed. So any thing, so most of the how you're going to perform this experiment from making gel to all these things. So now I'm moving to the lab, so I will show you different components. So how to, if you are, I mean, what different things are, how they really look like, even if you are coming to the lab, so how you are going to perform these things. So just a moment, I have to shift to the second system, then I will show you. Okay, just a moment. Okay, am I audible to you? Am I audible to you?
Yes, sir.
Yes, sir.
Okay, just a moment. I have to share the screen. Okay, so I'm going to the lab to show you different components. So one precaution you should take that while you are using these things, as I mentioned, the ETBR is going to be a bit carcinogenic, so must wear the gloves. So you can see, hope you are able to see it. So this is a casting tray. You can see these things are there. Okay. It is going to be your comb. Okay, so two different shape, different thickness, different size. You can make your gels. So different types of. This is also a casting tray. This is a smaller one. These are picture of different size. You can see it here. The small one is there, and but the longer one also you can make. So here also you can in the how much lengthwise, if you need more, you can make a lengthwise well. You can like well in this one is here. In another case, you can make well here also. So that depends upon what are you going to be your requirement. And this is going to be your the running unit. So it is going to have buffer. The buffer is there. You can see, and see some bubbles are there. I hope you are able to see some bubbles are there. So in it you can see this is a black, and it is going to be your red one. So black is negative, red is going to be the positive. So and where you have to place your sample into the well, and well should be toward negative one, because the DNA is also negative charge. It will move from the negative to the positive one. And this is going to be the power supply. So from where you're getting the power, so you can see the 101 is going to be your voltage that you are going to get it. So this is the electrodes are there. These two wires, red connect to red and black connect to the black. And when you run it, so when electricity to check whether electricity is passing or not, if the bubbling starts here, you can see here also. Simply means that it is running. Everything is in the circuit. So this is the electrophoresis thing, how to do it, how to place it. If someone of and to for the loading your sample in these well, utilizing your these pipettes and pipette tips, you have to suck the liquid and you have to place your sample inside the well. So this is a simple thing how to perform your experiment. Now I'm moving back. So this is, you can see, this is agarose bottle. This one, this agarose bottle is going to have agarose, and agarose is fine powder. Just a minute. You can see that it's a white powder, very fine. This you have to weigh and then dissolve to the buffer. Buffer is just like your solution. It is going to be a transparent solution, and then you can run your electrophoresis. Last one. Okay, students. So this is the. Okay, so this is the description of different components of your hydrogel electrophoresis that you have how to run it, and I think that video and some component that I've shown you, but really real experience you can get only if you come to the lab. So then only you can prepare your gel, because while you are preparing gel, many precaution you need to take, like as I mentioned, it is a electric things. So in electric things, one thing is the conduction, the circuit should be complete. If anywhere circuit got broken, then you are going to lose something. And one more, and the gel should be continuous also. If the gel is also discontinuous, then also there is an issue in the your running your gel. So while first precaution that you need to maintain while you are preparing your gel. So when you prepare your gel, means you can't pour very hot boiling gel. So boiling is going to have some bubbles also, and it your casting tray, they are going to be made up of fibers, or simply you can say plastic, and so they may damage them also. So you can't add very hot things. And second thing, one more thing is that you have to add ETBR. So ETBR is, as I mentioned, that it is a carcinogenic. So if you add this ETBR to a boiling one or very warm your solution. So then it is going to from warm solution it is evaporating, fumes are going to come out. So through the fumes that ethylene bromide may come to, or you may inhale that ethylene bromide also. So that also you need to check when it is become lukewarm and still liquid. Then you have to add the ethylene bromide and then you have to mix it. Okay, then you have to pour it. So once you added the ethylene bromide, you need to next step you need to care with the everything that you have to do with the gloves, because if you don't wear the gloves, then ethylene bromide may touch to your skin, and as it is potentially carcinogenic things, so every time threat of the cancer is there. Okay, so then comes to the loading the sample. So during at the time of loading sample also then an issue. So well, when you remove the comb from that, whether to check really right shape well are there or not. So for that taking out comb is also be a bit cautious, because if you uh, quickly remove it, then you may with the comb you may pick up your gel also, that may lead to the breaking up of your well. So well shape are going to be distorted in that case. So you should be gently remove the comb, okay, so that the well shape do not get disturbed. Then place, then you have, whether you have to place your gel into the buffer or you have to add buffer to the gel. So you have to place your gel in empty unit. Then you should pour your buffer over it, because what I think happens, these wells are empty, they contain air, they may trap air within them. So if you pour buffer over it, then air will come out. But if you put that into the gel, then sometime may chances are there the well may retain some air into them. Okay, so it's not like that, sir. Then we can't like if you have poured buffer into your unit, then you can't put the gel. You can, but you need to be extra cautious that the well is not having any air. So you have to just before adding your sample to the well, you have to check air is being removed or not. That's one thing. And next thing is that while loading also. So loading also, if some bubbles are there in your pipettes, in your pipette tips. So when you put your bubble into the well, with the bubble, your sample will also come out. So your sample must not have any air bubble into it. Okay, so that the loading is going to be smooth. And the loading is for the before loading, we have to mix tracking dye to it. So tracking dye is the one which track the migration, and tracking dye contains three different components. One component is the uh, glycerol. So glycerol, we are generally using 20% glycerol into them. That so glycerol, role of the glycerol is providing the density to your sample. So dense is going to be heavy. If you put it, then it immediately settle down. Okay, so it provides the density, one thing. Second thing is in it is going to be two different dyes. One is bromophenol blue and second is xylene cyanol. So this bromophenol blue and xylene cyanols, they are simply just providing the color to your sample. So they will help you whether the sample is loaded to the well or not, because blue color you can see, transparent color you can't see. So when you add a blue color dye, if you make your sample blue in color or red in color or any other color, so you can track whether the gel DNA is definitely going to the well or not. Okay, so for the two dyes we are mixing, what is the bromophenol blue, second is the xylene cyanol. So now you may ask why we are specifically adding these two dyes. So these two are also help in the tracking of what? Tracking of the migration of DNA. So whether your DNA is migrating over the gel or not. So because they are also being charged, they also migrate over the gel, and they also mimic the migration speed of your DNA also. Like I mentioned, two dyes here used. One is the bromophenol blue. Bromophenol blue migrate approximately, approximation I'm saying, I'm not it's exactly if you can to say, approximately it migrate with the speed of 500 base pair DNA. If your linear DNA of 500 base pair, what speed your DNA is migrating? It is migrating around that. Maybe a little more, maybe a little less, but around that 500 base pair migration is of your bromophenol blue. And the second is xylene cyanol. It migrates with approximate speed of 5,000 base pair DNA. Base pair linear DNA. Wherever I mentioned linear DNA because circular DNA we are not referring, because circular DNA, depending on its topology, it may migrate at different location. Okay, so these two dyes, they are migrating with some approximation speed of your DNA also. So they will help you to check up to what point your DNA has run. So like if you feel that your segment, your sample is going to have a very small fragment, they are going to be around 500 base pairs. So in that case, you cannot allow your gel to run. You cannot allow your dye to run out of your gel, because if dye run out of your gel, some of your DNA fragments also going to be run out. Okay. Second thing, if you feel that oh no, my gel is going to have very large fragment and size of my sample is going to be around 10 kilobase pair, so it means you do not you need not to bother where your bromophenol dye is, because if bromophenol dye is going out, then also may chances are there that your DNA still be near the well. So for that you need to track the migration of second color, that is of xylene cyanol. So you can track that xylene cyanol may reach up to the end, so that your DNA also is going to be in between of your gel. So why you can analyze the migration of your large size DNA. Okay, so this is the one, and now I'm sharing you the protocol one, so you can see how really what you have to perform. So whatever the steps shown in the video and whatever things I have mentioned you, all things are going to be there. So the first thing is the casting the gel. So when you start first the casting. So if you are casting the 100 ml gel, so on 1% you need to make weight 1 gram and add this 1 gram to 100 ml. Then put this into the, and this flask should be microbiable because you need to boil it. Then put the flask in the microwave oven and microwave for 1 to 3 minutes. Here you need to observe. So if I'm writing 1 to 3 minutes, you do not blindly follow the 1 to 3 minutes. You need to check whether the sample is boiling or not. As it got boiled, you need to turn off. You need to take it out, because if it boil like milk, if you're boiling, keep on boiling, then it will be spill out also. Then the agarose solution was to be allowed to cool it. So I mentioned it, you need to allow you to cool it because you need to add ETBR. So ETBR, you need to add few drops of the ETBR, few microliters. No, you don't need a very large amount. And it is fumes should not come. You should not inhale the fume. Then agarose solution poured into the gel, where you have placed all the, you have sealed it, and you all have to place the foam also. Then pour it. Okay, then you keep it for the 4 degrees Celsius to cool it down. When it completely solidified, then our thing is done. So next step is the loading the sample. So before loading, carefully place the electrophoresis tank after removal of the foam. So remove the foam and place it there. TE buffer was then added. So first place the gel, then add the TE buffer to the tank. Completely submerge the agarose gel. So agarose gel must be completely submerged. DNA sample were then mixed with the 5 microliter loading buffer. So now the loading buffer is, as I mentioned, the loading buffer is your gel loading dye, which is going to have 3 components: xylene cyanol, bromophenol glue, and the glycerol. The role I already told to you. Sample buffer mixture for then added to the pipette well. So with the using the pipette and transfer to the wells. So whatever the space that we made into the gel. Then the third step is with the electrophoresis. For the electrophoresis, you need to connect your electric leads with the your electrophoretic tank and to the power supply unit. So that's it. And then turn on the power supply and observe yourself, like observe the bubbles at the end. If the bubbles are there, it means connection are fine, it is running well. Then allow it to run for 20 minutes or till the blue dye, that blue dye is the your phenomenal blue, moves 3/4 the way to the gel. So here we are allowing only to move to the 3/4, because 3/4 means 70% of the path, because if you feel that some fragments are of 100 base pair, 200 base pair, they are going to be run out if you run it more. So for that we can allow only 75%. Then job is visualization. Visualization, you remove it, remove the lead, remove the leads, turn off the power supply, and carefully place your gel over the transilluminator. So transilluminator is of that type. You can see this blue one is going to have a UV lamp, and the glass is over there. So through that UV light is going to come out. Over that you have to place your gel, and then you can see these orange things that are there. That is your gel, and you can see the first lane is going to have a very distinct shaded band. These are going to be your DNA ladder. DNA is going to have a band of known size, so you can roughly quantify the size of DNA using it. Then other samples are going to have your DNA preparation, so you can see that long smears are there in it. So long smears means the DNA is going to be shared up. It's not an intact DNA. If a sharp band is there, then you can say DNA is going to be intact. So the sharp band is there only in the last well, you can say. And one more thing you need to observe that the well also, the way the well is there, so lots of the fluorescence is coming out of the well also. It means a large amount of DNA is still present in your wells. Means your size of your DNA is quite large, which will take more time to come out of your gel. So on the basis of observing the gel, you can give different whatever you want to, what we want to comment, what we want to analyze. We can analyze our gel, what is the state of your DNA is there. Okay, so precautions. So most of the precaution I already told you during the preparation of gel solution, but must not overboil. ETVR is carcinogen, so need to wear mask and gloves. So direct skin contact must be completely avoided. Pouring agrogel prepare must be prevent the air bubble. So air bubble is going to prevent the migration. Voltage should not be too high, because if voltage is going to be too high, it leads to the heating, or not too low, so that DNA is going to run very slow. The loading DNA sample must be done properly, prevent the air bubble. So while loading, prevent the bubbles, because with the bubble, your sample will not move into the gel. And place the sample above into the wells, not above or not below. So it must be within the well you need to place, not just if you're placing above or placing in very deep inside the well. So it should be just at the edge, or just it is just inside from the touching. You can simply can say from the upper surface to the inside. Okay. So secondary pipetting must be avoided. Secondary pipetting means while you are loading, you must not suck back. Okay, so don't avoid that one. So this is some precaution that you need to follow. Okay, so this is your experiment about the DNA gel electrophoresis. So I will now it's over you. So to ask any query if you have. If you don't have query, then read the literature that is available with you, or at least read the methods that I've shared with you. Okay, and ask the questions. Sure. Any query? Any query?
Sir, is it okay if
Yes.
you paste the link of the YouTube video that you showed us on the chat box, because many of us were able to view it.
Okay, I will share just a moment. I will share you the link.
Okay, thank you.
Because in the first class I shared you, I showed you 2-3 videos. So in this one I only show one video, because I was thinking that it is coming to you. Okay, one link I have shared you, and the second video I also sharing you the link.
Next, it's time to place the gel into the gel tank. The gel tank is a box with an electrode wire running across the bottom of each end. This
So
allows
both the link I have
current to
pasted.
pass, which will
So
separate
they will
nucleic
give you
acid
the
fragments.
clear picture of how we are going to prepare the gel, how we are going to place the gel
Correct
inside it.
orientation. Remember that nucleic acid.
Thank you, sir.
And is this
Agarose
is
gels
manual
are used
available
in
with you?
molecular biology for the separation and purification of nucleic acid fragments.
So the manual on your screen?
Yeah, manual that on my screen. Is it with you or not?
No, sir, it's not.
Okay, so today I will share it on the LMS also, so you can get it from there.
Okay.
Just a moment, I'm sharing it with you. Okay, so students, please check, visit your LMS. Is it there in the laboratory? In the laboratory section? Manaswini Nehal? Manaswini Nehal?
Yes, sir.
Is it there on your LMS?
Sir, I'm just checking.
Okay.
Yes, sir, is there.
Okay, so please everyone open the practical one that we are talking about. So read it, and after 10 minutes I will take your queries. Any doubt if you're getting from it, and then I will also create an assignment for you. So you have to upload your lab record of writing this everything on the your MS team for your laboratory number 5, I think. Okay, so please read it, and we will join back after 10 minutes.
ये इसको अलग करने का परमिशन आपने प्रैक्टिकल ऑनलाइन हो रहा है आप इनसे जाके चार देखो चार theory
Hope you read the protocol that I shared, and I think quickly you got the glimpse of that. Any question that you want to ask? Any doubt? No doubt. Everything is clear.
Yes, sir. Everything's clear.
Excuse me, sir.
Yes, Manaswini.
Sir, that was Nehal. Not me.
Manaswini, please type. Your voice is not coming very well, so please type in the chat box. I don't ask question. I have no doubts. Okay. So if none of you have doubts, please turn on your camera when I call your name. Adish. Adish.
Present, sir.
Atoiba. Atoiba.
Present, sir. Present, sir.
Ayushi. Ayushi
Present,
Jain.
sir.
Demetrius.
Present, sir.
Demetrius.
Present, sir.
Devanshi. Ishita.
Present, sir.
Janvi. Janvi. Kshitij.
Present, sir.
Manaswini.
Present, sir.
Namrita. Namrita.
Present, sir.
Nandini.
Present, sir.
Nihal.
Present, sir.
Rupal.
Present, sir.
Sahiba.
Present, sir.
Sanjana.
Present, sir.
Shakti. Shakti.
Present, sir.
Shivani. Tanvi.
Present, sir.
Tanvi.
Present, sir. Present, sir.
Tridev.
Present, sir.
Vivek. Vivek. Yukta.
Present, sir.
Yuvraj.
Present, sir.
Yuvraj. So Janvi. Janvi.
Present,
And
sir.
Vivek.
Sir, I'm present.
Okay, so thank you all. Stay safe, stay happy. See you again on Friday with our next session.
Thank you, sir. Thank you, sir.
Thank you, sir.
रक्षिता जी क्लास में थी कि मेरी एक
आपको सेंटर वाले सेकंड सेंटर हाँ very complete क्यों सर है ना हाँ हाँ ये रिव्यू की होती है ये छोड़ दो जो रिव्यू दिया इसमें वो एक्चुअली जो है इसमें है वीडियो हाँ वो यहाँ पे जो है ये चीज होता है हाँ ये वीडियो वीडियो और यहाँ पे जो है वो सारे वीडियो यहाँ पे ये है ना क्या डिवाइस वो आपको